And hello, everybody. Welcome to another fun-filled, exciting video about the human body, anatomy. And what we're going to be looking at today is we're going to actually start talking about the digestive system. And the digestive system is something that most of you are used to. You've talked about it since you're in kindergarten. You know it, the stomach, the small intestine, you know it has something to do with breaking down food. But what a lot of people don't realize is the stomach is not the main organ of your digestive system. And when you think about digestive, you think about breaking things down. But the whole purpose of your digestive system is to actually absorb those nutrients. And that does not happen in your stomach. So what we're going to look at is I'm going to break this down into different parts. And this video is just kind of an introduction to how we divide the digestive system up into what's called the alimentary canal and accessory organs. And then we're going to start looking at the mouth. Now, for those of you who know me, I use the anatomy coloring book by Capit a lot. And the version of the coloring book that I have, what we're going to be focusing on is on page 134 of the coloring book. But if you have an anatomy coloring book by Capit, we're looking for the one that talks about the digestive system overview. Now, when we talk about the digestive system, there are just a few terms that you might run across that sometimes people tend to get mixed up a little bit. And so when we look at ingestion, as a term you've heard before, ingestion is the real scientific name for eating. We are ingesting that food, we're putting that food into our mouth. We begin with digestion, food starts to be broken down so that we are able to absorb those nutrients. Now, digestion is where you actually break that food down. And in our bodies, there's two ways that our bodies can do that. We can do what's called chemical digestion, and that's where we use enzymes and we use acids and other chemicals to help break that food apart. So the moment you put food in your mouth, it mixes with saliva. Well, saliva has enzymes in it, and those enzymes are going to help our body start to take things like sugars and pull it apart. It's like taking, I have this huge Lego building, but I need the individual parts to build something else, so I have to take it apart. And so this is what digestion is going to be. And so anytime you use chemicals like in your mouth or in your stomach, that's what we call chemical digestion. That makes sense. Mechanical digestion is when you physically take something apart. So that would be like you chewing, or your digestive system, things like your stomach, your small intestines, your large intestines, they're made from smooth muscle. And if you remember, one of the characteristics of smooth muscle is that smooth muscle peristalsis. Remember, the peristalsis means it pulses. And so that pulsing is kind of like a trash compactor. As those muscles pulse, it helps smash that food and break it into smaller pieces, so it's easier for us to begin to pull apart. And then we have egestion, which is the elimination of solid waste. Now, our bodies get rid of three types of waste. We get rid of liquid waste, gaseous waste, and solid waste. Okay. Liquid waste is carbon dioxide. So that is your respiratory system. Excuse me, that's gaseous waste. Liquid waste would be things like sweat and urine. So it's your integumentary system and your excretory system. And then solid waste is fecal material. It's the leftover undigestible food products that we call feces. And then I know this got cut off on my head, but we have what's called absorption. And absorption is really the main purpose of the digestive system. Absorption is just what the name says. This is where we take those nutrients and we diffuse them, we absorb them into our bloodstream so that those nutrients can then, just like a conveyor belt, be taken to all the parts of our body in order to be used for something else. So if you think of digestion, like I said, as having this huge castle made of Legos, but you need to use those Legos to make something else, you've got to take that castle apart. That's digestion. So we'll take that castle apart into all these different little Legos, and then we can send those Legos to where they need to go so that we can make something else that our body needs. So when we look at the digestive system, we take the digestive system and we divide it up into two parts. And again, in my anatomy coloring book, this is page 134. And you will see where it says the alimentary canal, and it lists things like the oral cavity, the pharynx, the esophagus, the small intestine, the large intestine, and then you'll see where it has these things called accessory organs. Now, when we look at the alimentary canal, this is basically what you would call your food tube. This is one long, big tube that food just goes through. It's like this huge garden hose. And so these organs are hollow, and these organs have smooth muscle in them, and that smooth muscle allows them to periostose. So, your mouth is not an organ. Your mouth is an opening, and it's actually the opening to your alimentary canal. And then you go down the esophagus, which is what is commonly called the food tube. And your esophagus will periostose to help push food down, and it pushes food down into your stomach. And your stomach periostoses, that's why your stomach growls. Your stomach has a lot of fluid in it, and you guys know you could take a water bottle and shake it up and it makes bubbles. Well, when your stomach's empty and it's constantly pulsing, it's constantly churning, that gets bubbles moving around, and that's what happens when your stomach growls. And then from there, it goes into your small intestine, and then from there it goes into your large intestine, and then waste products come out of the anal opening. So our alimentary canal is just this one huge tube. Now, there are going to be doors along the way. So for example, you're going to see that there's going to be a door right here. There's going to be a door here. There's going to be a door here. There's a door here. And those doors, again, if you think about your alimentary canal as a huge garden hose, we don't want our food just all of a sudden pass through. Like if you have a garden hose, you put a ball at one end, it's going to roll all the way through. Our body needs time to break this food down. So along the way, there's certain doors that we can open and close in order to give our bodies time to break that food down. And so, again, I know this got cut off by my picture, but for those of you who, if you're actually in my class, I really like line diagrams, because I think line diagrams are a real easy way to remember, because you can very easily pull out a scrap sheet of paper and write your line diagram to figure out what it is. So when we look at the alimentary canal, we do go from the mouth to the pharynx, and my handwriting is very messy on these. Excuse me, to the pharynx, which is your throat, to your esophagus, to your stomach, to your small intestine, to your large intestine, and then out the anal opening. Okay, so that's what we call your alimentary canal. That's one really, really large tube. Now, from there, we also have these things that we call accessory organs. And accessory organs, oh, here's just a picture. So what we have here, you can see how the small intestines are these tubes. You can see the large intestine is a tube. Now, the liver and spleen are not tubes. These are examples of things that we call accessory organs. And accessory organs are still part of the digestive system. Just like when you accessorize, you put on jewelry. Accessory organs are still part of the digestive system, but food doesn't actually pass through them. So in the anatomy coloring book, you'll see teeth, tongue, your salivary glands, your liver, your gallbladder, your pancreas. These are all examples of what we call accessory organs. They're not hollow, so food never actually goes in them. Now, like I mentioned, your mouth is not an organ. Your mouth is the opening to your alimentary canal, but it's part of what we call the buccal cavity. Some people say buccal cavity or the oral cavity. And in that chamber, you have your teeth. Well, your teeth are part of your digestive system. You have 32 teeth as an adult, 16 on top and 16 on the bottom, and every tooth is a different organ. So your teeth are examples of what we call accessory organs. They're part of the digestive system. We use them for mechanical digestion. We use them to chew, but they're not part of the alimentary canal because they're not hollow and food doesn't pass through them. Your tongue is in your buccal cavity. Okay? It's made from skeletal muscle. Okay? It's used for many different things, but even though it's part of your digestive system, it's not part of that tube. So we don't call it part of your alimentary canal. It's an accessory organ. And so different accessory organs may do mechanical digestion, like your teeth. We use it to grind things. Your tongue is also used to help push food up on your teeth. They may do chemical digestion. Okay? They might secrete chemicals like your salivary glands. Your salivary glands make spit, but in your saliva you have mucus, you have different enzymes. Your liver helps secrete different chemicals. You're called bile. Your gallbladder helps with bile. Your pancreas makes something called sodium bicarbonate. All these things that we'll talk about when we're doing the digestive system. But in the case of these organs, the food never actually goes inside of them. So this is why they're considered to be accessory organs. Now, speaking of that, because food does pass through the tubes of your alimentary canal, and we mix that food, which is, you'll hear me say a bolus, B-O-L-U-S, or you'll hear me say chyme. That's the food as it's passing through our alimentary canal. It's mixed with lots of different acids. And you guys know that acids can break things down. So a lot of the organs of our alimentary canal are lined with mucus. Just like the inside of your nose is lined with mucus, and that mucus helps trap trash, the mucus in our alimentary canal is different. We have mucus in our mouth. You know that because saliva has mucus in it. Well, that mucus is there to help protect the living tissue inside of our mouth. So the acids and chemicals in the food we eat don't kill our inside of our cheek cells. And so as food passes through the esophagus, there's a little bit of mucus because it does have chemicals from the food and chemicals from your saliva. And your stomach has a ton of acid in it. So your stomach has this lining of mucus inside of it. So if this were your stomach, you'd have this lining of mucus. And that mucus helps protect against the chemicals. Well, that mucus is constantly getting broken down by the chemicals. So for example, your stomach is constantly having to make more mucus. Well, when people get ulcers, what happens is they can't make mucus fast enough. And so the acid starts to eat holes in the stomach lining. And you all hear, when people are really stressed, that can lead to ulcers. And the reason for that is we have what's called the sympathetic nervous system. The sympathetic nervous system kicks in under times of stress or times when we're upset, or it can even kick in when we're really, really excited. And the sympathetic nervous system causes things to speed up. So when you are stressed, your stomach pulses faster than normal. It churns faster than normal. So that acid spins around faster than normal. So the mucus gets broken down faster than normal. However, your stomach can only make mucus so fast. So if you're stressed and your stomach acid is spinning around faster than normal, you eat away that mucus faster than normal, and that can lead to ulcers. Now, like I mentioned, in the case of your alimentary canal, your smooth muscles are what make up these organs, and these smooth muscles constantly pulse. And this pulsing is called peristalsis, and that's to keep food moving through the tube. And every so often, you will have doors along the way. And we're going to talk more about the esophagus in a minute. That's what you would call your food tube. But in the case of your esophagus is part skeletal muscle and part smooth muscle. And if you remember, skeletal muscle is voluntary. You control it. But skeletal muscle can also feel. Smooth muscle is involuntary, but smooth muscle doesn't have feeling nerves. Because think about it. Imagine what it would be like if your smooth muscle had feeling nerves and you could feel things going through your intestines. Or you could feel the blood moving through all your blood vessels all the time. I'm not talking about taking your pulse. I'm talking about feeling everything going through your body all the time. Talk about brain overload. You would go insane. So smooth muscles can't feel things. But in the back of your throat, which we're going to talk about, a lot of people think if you shined a light down in the back of your mouth, you would see this big black tube, and you don't. The back of your throat dead ends, and it has two openings in it. One opening leads to your breathing tube, and that opening is called the glottis, and the other opening leads to your food tube, and that opening is called the gullet. And they're not open at the same time. If you think about it, you breathe more than you swallow. So your breathing hole, your glottis, is open 90% of the time. That's why when you talk, most of the saliva collects in the front of your mouth. But when you swallow, if everybody just takes a second to swallow, you have to think about swallowing. And it literally takes you a second or two from the time you say, okay, I'm going to swallow, to you swallow. And the reason for that is the door over your breathing hole has to close so that your food tube hole can open. And you have to be able to feel that happen. So the top part of the esophagus is skeletal muscle. This is what allows you to feel that you're swallowing. So when people say food went down the wrong tube, it literally went down the wrong tube. You have two tubes back there. And what happened is you swallowed or you inhaled something faster than you could close your breathing tube and open up your food tube, which we're going to talk about in a second. So in the case of your mouth, okay, like I mentioned, your mouth itself is not an organ. Your mouth is an opening. Okay? It's called your buccal cavity. Some people say your buccal cavity. These muscles here are called your buccinator muscles. Okay? These are the ones that let you open and close your mouth. They help with chewing. They help draw your lips in. Okay? So the mouth itself is not really an organ, but it is a chamber. It is a cavity, and it's made up from your lips and your cheeks. You've got your tongue in there. You've got your teeth in there. Imagine what it would be like if we didn't have lips and cheeks. Okay? We just had a skull jaw. Okay? When we try to chew, our food would fall out all over the place. We'd be like a crab. Okay? Crabs have this little opening, which is their mouth, and their jaws are outside of their mouth. And so you and I chew like this. Crabs chew like this. And they have these little things called pedipalps. And so as they're chewing, the food falls down. And some of the food gets lost, but some of the food gets stuck in the pedipalps. And then they take the pedipalps and they shove it backwards. So it's like me throwing food at your face. It's not very efficient. So by having cheeks and lips, that helps us hold our food into our mouth. So our cheeks and lips, you can kind of think of as what controls the opening and closing to your digestive system. Okay. That's my tongue. Okay. Your tongue is an accessory organ. It's in your mouth. Okay. It is part of your digestive system. It is made from skeletal muscle. You control it. You had to learn how to move your tongue around so that you can chew properly. That's why we can't give babies solid food. One, they don't have teeth, and two, they haven't figured out how to use their tongues yet. Okay? But in the case of your tongue, okay, one of the jobs of your tongue is to mix food with saliva. Okay? You have lots of salivary glands, and as you chew, the food rolls around and it gets mixed with saliva. And that's going to make, it's going to make the food soggy, so it's easier to fall apart. Saliva also has enzymes in it, so it's going to help start breaking that food down. Saliva has mucus in it, so it makes your food slimy, so it's easier to swallow. You guys have probably all swallowed like a dry cracker, and it just, you had a hard time getting it down, and it also didn't taste right. Well, I'm going to talk about that's because it didn't have that saliva mixture in it. Okay. Now, also when you're chewing, your tongue helps push your food up on your teeth. Imagine if we didn't have our tongue. We would chew, we'd have to scoop the food off, stick it on our tooth, chew, scoop the food up, stick it on our teeth. We don't have to do that. Right. It also kind of acts as a slide. So if everybody swallow again, your tongue goes to the roof of your mouth. Okay. And that helps block an opening that goes up to your nose, which we're going to talk about. And it also helps make sure that food gets pushed back towards the back. And again, this got cut off, but it's okay because it's the next slide. Your tongue is where you find your what's called papillae, and papillae are your taste buds. So speaking of papillae, anytime in anatomy you see the root word pap, okay? The root word pap means it's a fold. Okay? Now, throughout anatomy, I talk about SDF, and SDF is structure determines function. Well, something else that we're going to talk about is folds equals surface area. Okay? Folds equals surface area. The more folds you have, the more surface area you have. You're like, okay, well, what does that mean? Classic example, think of your hand. Okay? If we ate through our hands, okay, we suck things up with our hands. If our hands were like this, we could only suck things up here. We could suck things up here, and we can suck things up here. But we have folds. That increases our surface area. We still suck things up here. We still suck things up here, but now we can suck things up through here. So by having folds, that gives our bodies more surface area, which allows us to have more absorption or secretion. Well, in the case of your taste buds are these folds. And inside each taste bud, you have a nerve, and you also have blood vessels going into your taste buds. But in the case of your papillae, these are folds. Because remember, if you think of your fingers as papillae, as you're chewing, the chemicals from your food are getting mixed with water, and the water will flow through your taste buds. And your taste buds will start to absorb those chemicals, and that's what allows you to have your sense of taste. But when we look at your papilla, they are named according to their shape. Now, you can only taste 4 things. You can taste if something is sweet, which means it has sugar in it. You can taste if something is salty. You can taste if something is an acid, and you can taste if something is a base. That's all 4 things that you can taste. And you have taste buds that are specific to certain chemicals. They have to reach what's called a threshold. And so in the case of your filiform taste buds, these get their name because they look like filaments. They're long and skinny like your fingers. And these are the ones that allow you to taste if something is sweet or if something is salty. Now, one filiform can't do both. So we have some filiforms that just respond to sugars, and we have some filiforms that just respond to salts. But they're found kind of on the front and kind of in the middle of your tongue. Okay? The very, very middle of your tongue doesn't have a lot of taste buds. And that's because if you think about where we put food, we tend to put food in the middle of our tongue. So if there's a lot of acids in that food, or if that food's really hot, that's the part of your tongue that's going to get damaged. So nature has kind of evolved away from having a bunch of taste buds right there. And so that's why sometimes if you put food right in the middle of your tongue, you can't taste it. You have to wait for the water to mix and start to flow over your tongue in order for you to start to taste something. So like if you were to take something that's bitter, like soap, and put it right on the end of your tongue, you wouldn't taste it. You don't taste soap until it gets to the very back, which we're going to talk about in a second. But filiforms deal with your sense of something that's sweet and something that's salty. You then have what are called fungiforms. These look like mushrooms. So they look like fungus. That's where they get their names from. These respond to chemicals that are acids. And this is what gives us our sour taste. And they tend to be found on the sides of the tongue. And then way back in the back, if you stick your tongue out, you'll see what looks like these really big white circles. These are what we call your circumvallates, or sometimes it's called your vallates. And these are the ones that respond to things that are bitter. And forgive me if you need to go back. You can see all these things on page 135 in my coloring book. And it says the digestive system, the oral cavity, and relations up at the top. But you can see these circumvallates, these different tonsils that they have. These are the big round circles in the back. And these are things that respond to bases. Now, the circumvallates taste buds, the way that our saliva works, most of our saliva collects in the front of our mouth. That way we can breathe and we don't choke on our saliva. And so a lot of times, the only time you taste bases is when you swallow. So very rarely does food actually go to the back of your tongue unless you're swallowing. And so we talk about how foods have certain aftertastes. Well, if it's got an aftertaste, that means it had a base in it because you literally taste it after you swallow. Because it takes a minute, you swallow, and then it takes a minute for these nerves to turn on and tell your brain, oh, this had a base inside of it. And like we said here, these are the 4 things that you can taste. 90% of what you think you're tasting, you're actually smelling. Because as you're chewing, you're breathing. And as you're chewing, you're breathing in the chemicals from that food. And so you're smelling those chemicals. This is why food tastes different when you're sick. The food doesn't taste different. You're still tasting these 4 things. You just can't smell it.